Okay, so now we're going to talk about the very small stars. So these are less than 0.08 times the mass of the sun. Think about Jupiter. So Jupiter is going to be an example of one of these types of objects. Now, there's going to be people that disagree about that because Jupiter is a planet, whereas a brown dwarf forms from a cloud of material, and it's going to be one of these objects. However, from my point of view, I'm going to say that Jupiter is an example of a brown dwarf. It's an object that just did not have enough mass to cause enough gravity, to cause enough pressure, to cause enough temperature to get to that magic number of 10 million Kelvin. So these things, they never ignite. You don't need to know about the diameter of these objects, but you should know it's about the size of Jupiter. Don't worry about the density. Now you should know that the reason why Jupiter doesn't collapse and turn into a black hole, because that's what gravity wants to do to everything. Gravity wants to turn you into a black hole. But it doesn't because of the force of electricity and magnetism, which is holding your atoms apart. And that's stronger than gravity. This object, Jupiter, wants to collapse because of gravity. But it can't because inside of Jupiter there are gases that are moving with various speeds and because of their temperature. And that temperature is enough to cause enough pressure, thermal gas pressure, that will keep this thing from collapsing. So we're going to call this thing a brown dwarf. Got to know the name for the exam. As it cools off, it turns into a black dwarf. Got to know the name. So this object is basically just going to very slowly cool off. Currently, Jupiter is about 20,000 Kelvin. And so in the future, it's going to cool to absolute zero. And as it does so, it's going to start to shrink until it's an object that's about the size of the Earth. And then that's going to be a black dwarf. Okay, now it's going to, at this point, its temperature has gone to zero. So thermal gas pressure won't work anymore because now these molecules basically aren't moving because they don't have any temperature. So they don't have any kinetic energy. So this thing would start to collapse and would turn into a black hole if there wasn't anything pushing outwards. So now, instead of thermal gas pressure that's pushing outwards, it's going to be electron degeneracy pressure that's going to be pushing outwards. All right, so let's take a look at electron degeneracy pressure. Takes me a while to find all this stuff. All right, this slide here. Reasons why stars do not collapse. And so we talked about what thermal gas pressure is. So that's what's going to hold up a regular star. It's going to hold up the brown dwarf. So those objects, as long as they've got heat, they're being held up by thermal gas pressure. So let's look at electron degeneracy pressure. So here you've got two atoms that are getting closer and closer and closer together. Now we said that we could represent an atom as an apartment building. And so the electrons would live on different floors of the apartment building. So as these two apartment buildings are getting closer together, one of the electrons on one of the atoms might try to jump onto the other atom and live in a place where it's forbidden to live, according to the laws of quantum mechanics. And so that's going to be called electron degeneracy pressure. It's a pressure that's going to keep those two atoms away from each other. Otherwise, electrons would try to live in places where they're not allowed to live. Okay, let's go back to here. All right, so we just got finished with this one. So then the next step is, what do we do with objects that are a little bit bigger? So these are between 8% to 40% the mass of the sun. Our sun is not one of these objects. These are going to be relatively cool objects, so they're going to be the red dwarfs. So if you look at your HR diagram, these objects are going to be down here. So these are your red dwarfs in this region of the chart. So they're going to be smaller than the sun, but they do ignite. They do have enough mass to cause enough gravity, to cause enough pressure to get to a temperature of 10 million Kelvin. So they do ignite. They convert hydrogen to helium. But that's it. That's all they can do. Now eventually they're going to start to run out of hydrogen. And when they run out of hydrogen, they're going to die. They're slowly going to cool off and they turn into a black dwarf. The same thing that the brown dwarf turned into. And notice that gravity is countered by electron degeneracy pressure. The same thing. All right, let's take a break. When we come back, we will switch and we will talk about medium-sized stars.